From mysterious explosions to hidden messages in Starlight, our cosmic neighborhood holds secrets that scientists are just beginning to understand. Today, we'll explore how ancient stars are changing everything we thought we knew about space. When massive stars die, they don't just fade away quietly. They go out with a spectacular bang called a supernova. These cosmic explosions are like time capsules, sending messages across billions of light years that we can finally decode. The light and elements released tell us amazing stories about how these stars lived and died. By studying the different colors and patterns in supernova explosions, scientists can figure out what ancient stars were made of, how big they were, and even their age. Kind of like cosmic fingerprints. Each explosion leaves behind unique chemical traces that work like a stellar diary, revealing secrets about the early universe. What's really exciting is that new telescope technology lets us read these cosmic messages better than ever before, giving us a front-row seat to some of the most powerful events in space. Here's where our story takes an odd turn. Astronomers have noticed something strange in their star surveys. Based on our understanding of how stars form and evolve, there should be certain types of stars out there that we just can't find. It's like having a family photo with an empty space where someone should be standing. Scientists expected to see massive stars with very specific brightness levels and chemical makeups, especially from the early universe. But when they look for these cosmic giants, they come up empty-handed. This mystery has made researchers question what we know about star formation. Some think these missing stars might have taken unusual paths we haven't discovered yet, while others suggest they could be hiding behind cosmic dust clouds. The search for these dark stars continues, pushing us to rethink the rules of stellar evolution. The elements that make up Earth, from the iron in your blood to the gold in your jewelry, all came from ancient stars. When scientists look at the light from old stars, they can spot unique patterns that show exactly which chemical elements are present. Think of it like a star's recipe card, listing all its ingredients. These stellar fingerprints tell us that heavy elements like gold and platinum were cooked up when neutron stars crashed into each other billions of years ago. Meanwhile, lighter elements like carbon and nitrogen came from regular stars that exploded as supernovas. By matching the chemical patterns in ancient stars with the elements we find on Earth, scientists can trace our planet's ingredients back to their cosmic sources. It's amazing to think that every atom in your body was once part of a star. Let's talk about some rebellious stars that don't play by the rules we thought all stars followed. These cosmic rebels show up in places they shouldn't, shine in ways that seem impossible, and live far longer than we expected. Take the blue stragglers. These stars look way younger than their neighbors, like teenagers hanging out at a retirement home. Then there are stars that spin so fast they should tear themselves apart, but somehow stay together. We've also found stars that contain elements that shouldn't exist at their age, like finding a smartphone in ancient ruins. These oddball stars are forcing scientists to rewrite their textbooks. Some might be stealing material from companion stars, while others could be the result of stellar mergers, like cosmic car crashes that create something entirely new. These discoveries show us that the universe is even stranger and more creative than we imagined. Let's explore one of the most amazing things about Starlight. It's actually a window into the past. When we look up at the night sky, we're seeing stars not as they are now, but as they were thousands or even millions of years ago. This happens because light, even though it's incredibly fast, still takes time to travel through space. Every beam of starlight is like a message in a bottle, carrying information about what the universe was like when that light first started its journey. Scientists can use special tools to break down this ancient light and learn about things like what elements were around billions of years ago, how the first stars formed, and even how fast the universe is growing. Think of it like reading a very old letter that's been traveling through space. Each star's light tells us a unique story about what the cosmos was like long ago. Some stars are masters of disguise, playing tricks on astronomers by appearing completely different from what they really are. These cosmic tricksters might look young and bright, but they're actually ancient stars wearing a deceptive mask. Take blue stragglers, for example. These stars appear much younger than their neighbors because they've stolen material from companion stars, giving themselves a fresh blue appearance. We've also found stars that hide their true age by swallowing nearby planets, which speeds up their rotation and makes them look more youthful. It's like they've found a cosmic fountain of youth. Even more fascinating are binary stars that exchange material, making it hard to tell which one is older. These stellar disguises have taught astronomers an important lesson. In space, appearances can be very deceiving. Here's a space mystery that's puzzling astronomers. Giant stars are vanishing without a trace. Think about losing something as big as 1,000,000 suns. That's what we're dealing with. Normally, when massive stars die, they put on a spectacular light show called a supernova. But some of these stellar giants seem to be slipping away quietly into the night. Recent telescope surveys have caught a few stars just disappearing. In one case, a bright star in a distant galaxy was there in 2009, but by 2015, it had completely vanished. Some scientists think these stars might be cloaking themselves in huge dust clouds they create before their death. Others suggest they might be collapsing directly into black holes without the usual fireworks. Whatever's happening, these disappearing acts are changing how we think about the final moments of giant stars. Let's dig into the oldest stars ever discovered, the cosmic pioneers that lit up our universe for the first time. These ancient stars were unlike anything we see today. They formed from pure hydrogen and helium, since heavier elements didn't exist yet. Imagine stars up to 100 times bigger than our Sun, burning so hot and bright they could outshine entire galaxies. While most of these first stars are long gone, astronomers have found a few of their descendants, rare stars with very few heavy elements. These cosmic fossils help us piece together what the early universe was like. By studying their light and chemical makeup, we can map out how the first stars created the building blocks for everything we see today. It's like being cosmic detectives, using these stellar clues to solve the mystery of how our universe began. Stars might look peaceful from Earth, but they're actually humming with sound waves we can't hear. These vibrations work like musical notes traveling through the star, bouncing from the surface all the way to the core. By measuring how these waves move, scientists can figure out what's happening deep inside stars. It's like giving them an ultrasound. When stars vibrate, they create patterns of brightness changes that we can detect with special telescopes. These patterns tell us amazing details about a star's age, size, and what it's made of. Our Sun, for example, has millions of different sound waves bouncing around inside it right now. This technique, called astroseismology, helps us understand stars better than ever before. It's teaching us that stars aren't just giant balls of gas. They're complex instruments playing cosmic music we're just learning to understand. Let's explore some amazing stars that seem to break all the rules about how long stars should live. Scientists have found stars that should have burned out billions of years ago, but they're still shining bright today. These stellar survivors use clever tricks to extend their lifespans. Some steal gas from nearby stars like cosmic vampires, while others burn their fuel super slowly, like a campfire that barely uses any wood. We've even discovered stars that should have exploded long ago, but instead found ways to stay stable. These hardy stars are teaching us that stellar life isn't as simple as we thought. They're like the tortoises of space, slow and steady, outlasting all expectations. By studying these survivors, astronomers are learning that stars can be much more resourceful than we ever imagined. Thanks for joining me on this stellar journey through space's greatest mysteries. Every star has a story, and we're just beginning to understand them all. If you enjoyed these cosmic revelations, hit like, subscribe, and share to explore more space secrets together.